When we think about habitats on Earth, we tend to picture forests, oceans, grasslands, places we can hike through or paddle across. But one of the planet's most important habitats is one we almost never think about, the air above us. Stretching 10 to 12 kilometers above the ground, Earth's lower atmosphere, the troposphere, is the largest habitat on the planet. In sheer volume, it's 5 times larger than Earth's oceans, and it's filled with life. Trillions of organisms, birds, bats, and insects move through this space. They migrate, forage, ride thermals, and even sleep on the wing. Yet despite its size and importance, the lower atmosphere has rarely been treated as a true habitat. We don't map it like we do wetlands and forests. We don't protect it in the way we protect coastlines. It is an enormous ecological stage, but for decades it has remained largely invisible to us. So how do we study a habitat we rarely enter? One that stretches thousands of meters above our heads. One of the most powerful tools to study the atmosphere is weather surveillance radar, the same network of radars used to track storms. Across the United States, more than 140 NEXRAD radars scan the sky every few minutes, quietly collecting information not only about rain and snow, but also about flying animals. These radars give us something we've never had before, a continental scale view of how animals use the airspace over a full 24-hour day. In our research, we analyzed over 100 million radar scans spanning 28 years across the contiguous United States. We focused on a simple question with big implications. How do migratory animals use the aerial habitat through the day and night? The answer is clear. We found that migration overwhelmingly happens at night. About 88% of activity detected by radars in spring and autumn occur after sunset. We also learned that these travelers use a surprisingly narrow slice of the sky. At the nightly peak, about 4 hours after sunset, half of all migratory movement is confined to a band of only 500 meters tall, starting just a few hundred meters above the ground. Think of a busy aerial migration highway draped above our heads, structured in space and time, not a random swirl of movement, but a habitat with organization and patterns. And this matters. Robert MacArthur's ideas of niche partitioning nearly 70 years ago transformed how we understand ecological communities. But applying these concepts to the lower atmosphere has remained out of reach. Migration changes that. Hundreds of species travel through the airspace simultaneously, forming patterns in altitude, timing, and movement. With radar, we can finally quantify this structure. To protect species that rely on the sky, we first need to understand how they use it. Our work shows that the lower atmosphere isn't just empty space, rather, it's a living, dynamic habitat structured in ways we can now measure thanks to radar. By viewing the sky as habitat, we open the door to new conservation strategies, better forecasting tools, and a deeper appreciation of the life happening above us every night.